Hello everyone. So I'm going to do a video which will go through the midterm exam because we lost uh, some of Wednesday's class or a large part of Wednesday's class. So I'm going to go through. I'm not necessarily going to do all of it, but I'm going to do most of it so you can see how you should have answered. All right. So I'm going to share my screen two. So it's got this in the way. Let me move this. All right. So. That's there. So, this is the exam that you did. I think this is the right class. This is the exam you did. This is the data. And so I'm just going to work through it. I'm going to do everything in Excel. So this is going to be question one. Right. So question one is Americans read 5, 6, 8, 2 words a day. So this is obviously the average or the mean. Yeah. With a standard deviation of 738 words. My observation, so this is 6529. What percentage of the population reads more? So I'm just going to go to use the normal table because the normal table is going to tell me a couple of things, right? So I really need to know, how many standard deviations away am I from the mean? How many Zs effectively? So this, I will estimate my Z score, which is going to be equal to bracket observation minus mean bracket divided by standard deviation. So I'm 1.147. So I'm going to look up, that's going to be close enough to 1.15, right? That seems kind of close enough. So I'm going to go to my tables and look up 115, 115. So that's 1251, I think. Let me see if I can make that bigger. 1251. So, or 12, do one. Right. So this is the close enough. That's the percentage that I'm looking for. That's the answer. 12.41 reads more than me. Very easy going to the table. Next one is I know that the Americans on average read 5,682 words per day. I want to know if Cal Poly students read more. So my N is 22. My mean of the sample is 6,234. And my standard deviation is equal to 1,002. So a couple of things I've got to work out. First, I've got to work out the t-score. Then I've got to work out the standard error. So the t-score, I'm going to go to the t-table. I have an n of 22. So that means I'm looking for of 21 degrees of freedom. So 21, of course, this is under the thing. 21, so that's my t is 2.08. Yeah. Then my standard error is simply going to be equal to the standard deviation divided by square root of n. So standard error is 213. So my lower confidence interval is equal to the mean minus bracket t times standard error. My upper is equal to mean plus bracket error and 600. So I want to know if Cal Poly students, so my best guess is actually simply equal to the mean of my sample. Yeah. And this is my confidence interval, upper and lower bound. And yes, I am confident that they're different, aren't I? Because 5, 6, 8, 2 is not in the confidence interval. I'm confident they're different. It's question 2. Yeah. Very simple, going through each stage just very easily. All right. Exam 1, create 2 new variables, measure percentage of male and percentage of female, summarize all variables and identify the best measure of central tendency. To create a histogram of percentage female, pivot table organized by region. All right. So the first thing I'm going to do is I'm going to create region 1, and this is going to be Midwest. This is Northeast. This is South. And this is West. Yeah. That's just going to make the pivot table look better. There are other ways of doing it, but I'm just going to do it very quickly. Yeah. Now, I'm going to create my new variable. So it's male percent. And I'm going to create code book, female. Yeah, fairly easy. Now I'm going to just make this as a percentage. So male percent is going to be equal to number of males divided by the total population. That would be a proportion. So I want to multiply it by 100. And because I'm just going to put this $ in front of the D there, because it's going to make the next bit a little bit easier. So 49%. I'm going to drag across. You see, by putting the $ in front of the D, I've stayed in that column. I'm going to highlight. I'm going to then format these to make them look good. Number, 2 decimal places looks good. Yeah. And that's that created. Now I'm going to, so I've created those new. I'm going to summarize all the variables. So I'm going to, let me cut this and insert it in front of region. I'm now going to go to data analysis toolpath. I'm going to do descriptive statistics. And because I've moved the region, that means that I can highlight all of these and then say labels in first row, summary statistics, click OK. So what I would do here is bigger. So that would be, and that is south. So that would be the mode is south. Then in terms of population, I would use the median because they're different. In terms of all of these, I would use the median because the mean and the mean and the median are so different. But in terms of percentages, you see that these are very similar. So I could use either the mean or the median here to describe the group. That either would be perfectly fine. These look pretty reasonable. So yeah, I don't think there's any big mistakes in the data. Nothing that jumps out at me being a big mistake. The maximum population, I assume that's California. So yeah, 39 million. Yes, right. So that's that data set constructed. Now I'm going to do the pivot table. So I'm going to do a pivot table, insert pivot table from this data to a new worksheet. I'm going to go region, and I'm going to do the average percentage of male and female, dump those both in, change them from sums to average. And that's the pivot table. Yeah. Rename pivot. Oh, this is rename summary statistics. And the last thing I've got to do, I think, let me pull this up. Last thing I've got to do is create a histogram percent female. That's easy. So let me go and look at the sum statistics. Percent female goes between 47.5 and 52.5. So let's say data analysis, histogram, input range, female, bin range, bins, labels, chart output. Click OK. Yeah, so I've got these two at the end, so I'm going to delete these. This, and delete this. Yeah, that looks okay. So I'm going to do this, change this to figure 1. And female in US state. Less than 48%. Yeah. Then yeah, so I'm going to go through each of these, but I'm not actually going to do that because I can't be bothered. But this is, but you should do that in the exam. You know, I might get rid of this and just say less than 48.5% or, but either way, no, I think I'd probably keep that in and go up to, you know, all the way up to, yeah. Then that's that figure done. I'm not going to do the rest because it's just going to take time. But this would be, I'm going to rename this hist. And that's that question done. Yeah. All seems to be right. Right. So from the soccer data set from the soccer PDF, create a data set for goal scorers with player unit of analysis, create new variable reporting goals per games, and best message central tendency. All right, I think I've got time to do this. So I'm going to call this soccer. All right, and then I've got my soccer PDF, so it's going to be organized by name. It's name, season, club, match, goals, and assists, but of course, season is a constant, so I'm not going to include that. I'm going to include club. I'm going to code these, so this is club. And then there are two things. Like generally, if you were making a data set on goals scored by players, you would definitely code club because there'll be multiple players who score goals for the same club. Here, these are the top scorers in the 2024-2025 season. So there's only one player on each team. So I am still going to create a code book, but if you didn't, it's not that big a deal. Generally, I would have done this alphabetically because every club would have been involved because each club would have had, goal scorers. But I'm just going to go through and do this for the ones that are there in just the order that they were. So Brentford 5 is going to be equal to Manchester City 6 equals Aston Villa 7 equals Nottingham Forest. All right, I want to put plus Man City, even of course it's equal Man City. So that's the code book. This is so number of matches played. Number of assists. So now, first thing I have to do is, should I use people's names? Well, actually, I should. This is public data, right? Like, it's not like that millions of people didn't see Mo Salah score these goals for Liverpool. So I'm going to put in Mo Salah's name, Mohamed Salah. I could call him M Salah if I wanted to. I could just refer to him as his by his family name, but there might be repeat family names. So goals 29, assists 18. Then it's Alexander Isak, and he played Newcastle and played 4 matches, 23 goals with 6 assists. Then, so I could do this the whole way through, right? For everyone, Brandon Bomo, Erling Haaland, Ollie Watkins, and then Chris Wood. I could do that for each of them, but I'm not going to because that's just typing in. But I'm going to create the variable which is goals per game. I'm going to note this. Goals scored per game played, and that's simply going to be equal to goals divided by matches, I think. Yeah. So, you know, if you made this a percentage, that would be okay as long as you coded it as a percentage. But this is really, you know, Mo Salah scored, you know, basically 0.76 goals per game, right? That's what he would, if you were expecting. And Alexander Isak, you know, basically was expected to score like 2/3 of a goal a game. Do that for everyone. Now, when we're talking about measures of central tendency, I wouldn't measure central tendency for name because it's always unique. I would do the mode for club, but nothing's going to come up here because they all appear once. I would do the median or the mean for number of matches. They're probably going to be reasonably similar, so it won't matter. Same with goals, same with assists, same with goals per game. And that should be it. That's a very simple. I think that was all that I was required to do. Yeah, that was it. All right. So that would have been the exam. Okay, so I'm gonna post this and post the answers or an answer version online, and I'll see you in class on Monday. Bye bye.